Hey there, so we're going to talk about quadratic inequalities, and I'm not going to waste any time. Let's just get right into it. So what is a quadratic inequality? So quadratic inequalities, like they sound, so it's a quadratic equation in an inequality. So it could have a form like this: ax squared plus bx plus c is less than 0. A, b, and c are real numbers. It doesn't have to be the less than symbol. You can also have less than or equal to, greater than or equal to, or greater than. And this form actually is pretty useful to remember in that you want usually everything on one side when you're trying to solve a quadratic inequality. So I want to take a look at how to solve a quadratic inequality with an example. So let's use the example x squared minus x minus 6 is greater than or equal to 0. And usually you're going to want to put your answer in interval notation, which is not going to be a big deal when you see how we set everything up. Okay, so there are 3 steps to solving these. Step 1, you want to solve the corresponding quadratic equation. So what I mean is, if you have everything on one side like we do here, instead of having this now greater than 0, let's set it equal to 0, and let's just solve this. And you know how to solve this, right? So you just factor it, so it's x minus 3, x plus 2. And then my 2 solutions in this case will be x equals 3 and x equals negative 2. So that's the first thing that you want to do. The next thing that you want to do is you want to create intervals based on the solutions. So my 2 solutions, right, were x equals 3 and x equals negative 2. Now, I think the easiest way to figure out those intervals is to plot those solutions on a number line like you see here. So here's where negative 2 falls, here's where 3 falls. And so basically now what that does is this creates 3 separate intervals for us to test. So this is the first part before negative 2, between negative 2 and 3 is the second interval, and then 3 on is the last interval. And okay, so we're going to use these intervals to create a table. That's why we care about this. That's why we want to have the visual. So the way to think about this, I'll just add on to this. So the interval goes, so over here, this goes from negative infinity all the way up to negative 2, okay? And then we go from negative 2 to 3, so negative 2 to 3, and then 3 to infinity. So okay, that hopefully makes sense. If you're not familiar with how interval notation works, this might be a little tricky for you. And I do have a whole video where I break down interval notation. It's a thing that people forget sometimes, so no big deal if you forgot it. You're just going to want to go back and review it, so I'll drop a link to that in the description. All right, so what does this table look like? So think about the 3 intervals I was just telling you about. What we're going to do is we're going to take each of those intervals like you see here, so negative infinity to negative 2, negative 2 to 3, 3 to infinity. We're going to set those up in an interval column, and then we're going to have a second column for a test point, and then that test point is going to give us either a true or false. And so setting up this table really brings us to step 3 in this process, which is to use test values to find the solution set on the table. Okay, so table. So I guess you could think of the table as either a step 2 or a step 3 thing. But anyways, we talked about how to set up this table. So now what I want to do is I just want to isolate our view on the original problem, okay, and that table. And so when you choose a test point, it literally doesn't matter what number you choose. It just has to be something in this interval. So from negative infinity to negative 2, a number that falls in this interval would be something like negative 3. So you can use the number line too if you get a little confused as to what number to choose. So I just choose something small, negative 3, easy to calculate. And so what I'm going to do is I'm going to take that negative 3 and I'm going to plug it into this inequality. So like this. So now I replace the x's with the negative 3, and I'm just going to work this out and see what I get. So if I work out the left side, so this will come out to the statement that 6 is greater than 0. So this whole side here will work out to 6. So you can prove that to yourself if you want. And so then, now you just have to say to yourself, so is this true or false? Is 6 greater than 0? So yes, that is true. So, boop, write a true right there. There we go. All right, so moving on to the next interval. So let's choose another number now between negative 2 and 3. Now, of course, if you're in an interval that goes over 0, then you probably want to choose 0, right? Because that's just the easiest number to do a calculation with. And it's the same idea. So I'm going to take that test point and I'm going to plug it into this inequality here. So here you go. I've plugged it in. And hey, this is great because it's really easy to do the math on this. So if I work this all out, this will ultimately give me the statement that negative 6 is greater than 0. And so then you just have to say, is that true or false? And you, of course, are saying that is False, Prof. Hill. You are correct. And so, okay, now we move on to the last interval. So what would be a good test point for this last interval? I like to keep the number a whole number if I can, and I like to keep it as small as possible. So the smallest whole number I could choose would be 4. And then, once again, I'm going to plug 4 into this entire expression just to see what I get. So I plug everything in. I get the expression one more time that 6 is greater than 0, and we already said that that's true. And so, okay, cool. We are good to go on this. All right, so now what do we do with this information? Well, now actually we have everything we need to finish this. So the two true intervals, those are what make up the solutions. And so what the answer actually is I take these two intervals. Now, something that I want to point out here that we'll talk about as we're going through some of these problems is when you're doing your interval notation. So this is probably the most confusing part. You do have to think about what sign you have here to decide whether or not you want to actually include those numbers. Now, in this case, this is just greater than, so the solutions will not be included. But when we get to like greater than or equal to or less than or equal to, we just have to be careful. So with that being said, just keep that in mind. I'll go through a few more examples with you, and then I think it'll start to make sense. Okay, so this next example is doing exactly what I was kind of pointing out. So I've got 3x squared minus 4 is less than or equal to x. Okay, so one thing that I just want to point out here is maybe like, you know, if you're in that what I like to call like robot mode and you're not like thinking about what you're looking at, you might just try to like go forward and solve this. But the big key here is that this is 3x squared. So the second you see that 3x squared, it's, oh, okay, this is a quadratic inequality. And so since it's a quadratic inequality because I have this x squared, what I have to do is I have to bring this x over to the other side. It just makes my life so much easier. So I'm going to rewrite this as 3x squared minus x minus 4 is less than or equal to 0. Okay, so I'm going to walk through this one with you piece by piece. And remember, I always say that math is not a spectator sport. So what I recommend that you do is just go along with me and we'll make sure that you understand this. So the first thing that you've got to do, right, is you've got to set this equal to 0 and solve it. So why don't you go ahead and do that, and then when you think you've got it, hit play when you're ready. Okay, so in the interest of time, so I'm going to take this and set it equal to 0. And okay, so now I've got a factor. So let's see, how does this factor? So I'm going to have, I think this is just going to be minus 4 and plus 1. Let me double check my math here. So let's see, this gives me 3x squared plus 3x minus 4x minus 4x minus 4. So yep, that gets me the thing in the middle. So sometimes you have to play around a little bit with the factoring. When you're working through stuff like this, they're not always going to give you like the easiest thing to factor. So you might have to work at it a little bit. No problem though. And okay, so now I've got 3x minus 4 equals 0 and x plus 1 equals 0. So I just solve each of these. So I get that x will equal 4 over 3 or x equals negative 1. So those are my two solutions. So I'm just going to note that over here. So x equals 4 over 3, x equals negative 1. And now what I want you to do is I want you to determine what are the three intervals that we're going to have in this case. So maybe take a second to pause and draw a number line and try to figure out what you think the intervals should be just to make sure that you understand how that works, and then hit play when you think you've got it. All right, so I'm going to go ahead and draw this. So let's see, I'll put this here. So here's negative 1. Here's 4/3. And okay, so the first interval is going to go from negative infinity to negative 1. The next interval is going to go from negative 1 to 4/3. And then the last interval is going to go from 4/3 to positive infinity. So just take a second to make sure that that makes sense to you and that you're good on that. And so now what we've got to do is we've got to set up the table. So this is the next thing that I want you to set up is the table. And I actually think if you've got the table set up, you should just try to finish this problem in its entirety and then hit play when you're ready. So pause here, hit play when you're ready. All right, so I'm going to go ahead and set up that table. So I'm just going to flash it on the screen. So let me just erase this and draw the table. So there's some space and here's the table. Okay, so I've got my table. So now I'm going to start choosing some points. So let's see, I'll choose negative 2 as my first point. And then as far as like which equation should you substitute this into, so I'm actually going to sub it back into the original equation. You could have done it in this and you would have gotten the same conclusion, but I just like going back to the original. Okay, so let's see. If I plug that in, so I get 3 negative 2 squared minus 4 is less than or equal to negative 2. So if I sort that out, this will turn into 8 is less than or equal to negative 2. So that is false. No. Okay, so the next test point I'm going to use is 0. So let me clear some space. And so I can plug in 0. So I get, let's see, this. And this is going to be nice and easy to calculate. So this will simplify to negative 4 is less than or equal to 0. So that is definitely true. And then for my last point, so 4 over 3 is like 1 1/3. So the next largest number I can come up with is 2. And so if I choose 2, so let me clear some space. And so then I get this statement, and if I work this out, I get, let's see, 8 is less than or equal to 2, which is also false. And so now you see that in this particular example, we just have the one interval that worked out as our solution, which is totally fine. No problem with that. Now, here's the tricky part. Here's like the last thing that you've got to think about is what do you do now because we have this less than or equal to. So when you have less than or equal to, for the actual numbers will get included in this solution set. So what's the final answer? Let me clear some space. The final answer in this case is going to be -1 4/3. And this is purely a consequence of having the less than or equal to, which means that we want to have that or equal to and include these points. Now, one thing I want to remind you, infinity and negative infinity always, no matter what, get round brackets, okay? So the numbers can be included if you have less than or equal to, but if you had something like, let's say that this was the solution, I would give a square bracket for -1, but not for negative infinity, because infinity and negative infinity, they're not actual numbers, so they always get a parenthesis. A square bracket means that that number is included. Infinity is not a number, it's a concept, therefore it can't actually be included. Alrighty, so I have one more here for you guys. And you might look at this one and say, oh, I wouldn't have thought this was a quadratic. So yes, even though it doesn't have an x, like a regular x in it, it still has x squared, so it's still quadratic. So we still use the same procedure. So you want to move the 25 to the other side. Now, I think you should pause the video and just see if you can do this entirely, because I think if you can do this entirely, then you're probably in a good spot. So pause here, hit play when you think you've got it. And so I'm just going to run through the solution now. So I've got x squared minus 25, so I want to set that equal to 0. And of course, I can factor that x plus 5 and x minus 5. So my two solutions in this case are x equals 5 and x equals -5. And so I don't need to set up the number line. I'll just tell you what the intervals are in this case. And if you have the number line set up right, then you will get these intervals. So let's see, I will do my intervals, and then I'll do my test point, and then I'll do my true or false. So my first interval will go from -infinity to -5, -5 to 5, and then 5 to infinity. And so now we can choose some test points. So I'll choose -6. So if I plug -6 into my original expression, so I have -6 squared, is that greater than or equal to 25? So yes, that's 36 is greater than or equal to 25. So that is true for sure. Okay, so next test point that I want to choose is 0. So I'll clear some space. And so that's going to give me that 0 is greater than or equal to 25. So that's definitely false, right? And then for the last one, so if I choose 6, I'm going to get the same result as when I did -6. It's still going to give me 36 greater than 25. So this is going to be true once again. And so in this case, now I have two intervals. Let me erase this real quick. Okay, so now, $1,000,000 question. What's the answer? Did you write it down? I would take a second to write it down if you haven't. Okay, so the answer, so remember, -infinity does not ever get a square. but -5 would be included and 5 would be included, and it's because we have that greater than or equal to. So that would be the final answer. So hopefully that kind of clears up some of the weirdness with the greater than, equal to, all that good stuff. Okay, so that brings us to the end of this video. If you found it helpful, please consider liking it, leaving a comment, subscribing to the channel. I'm trying to make a nice free channel. I have a lot of other things I want to do with this channel, as I have time and money to kind of add some other resources to it. So every little bit helps. Whenever you hit the like or subscribe button, I super, super, super appreciate it. And otherwise, I will talk to you guys in another video. Thanks for watching.